1.7 exponents and roots. All numbers have a base and an exponent. The symbol for an exponent is called a caret. That's this little figure right here. So even if I were to write your favorite number, 7. I think that was your favorite number. Was it Kat's favorite number? I don't know. 7 or 15, right? If I wrote 7 to the first power, it's the same thing as just writing 7. So if you think about it, every number in existence always has an exponent, right? Or if I wrote 15 to the first, that's 15, in which this is called the base. This is called the exponent. They're going to give you terms again. This can be written as 12 squared. So we're going to call that exponential form. You could also write it as 144, 12 times 12. That's going to be standard form. And then lastly, (12 times 12), right? So if something's to the squared, it means there's 2 of them multiplied together. This is going to be repeated form, is the way the computer is going to ask you. Rules to remember: anything to the 0 power is 1. All these strange rules you got to remember. So anything multiplied by 0, 12 times 0 is 0. But 12 to the 0 power is always 1. The question is, why is it like that? I don't know. They just came up with that rule a long, long time ago in algebra. I think that exponents, the key to getting used to them is to do a lot of practice. So there's just a lot of examples there. Eight to the second power, 64. 6 to the second power? 36. 4 to the 0 power is 1. Doesn't matter what it is. 0 power is 1. All right, 9 squared? 81. Okay. Got to think about it a little bit. 5 to the third power. It's the same as saying 5 times 5 times 5. There's 3 of them. Is, what did you say? 125. So you have to do 5 times 5 is 25, and then 25 times 5. And then 3 to the first power. 3. Are there any tricks that I want to talk about here? No. We're good. Those are your terms, right? Find the factor, form, or repeated multiplication for 6 to the fourth power. Yeah, write all the 6's out. Why am I doing this problem? Because in the homeworks, you've got to write that dot. And then standard form, 6 to the fourth. 1296. Just multiply it out. Questions about exponential notation, factor, or repeated form, standard form? Okay. Roots are the inverse of exponents. Which ones am I missing? Another one. copy all of them. Oh, this one. Okay. Roots are the inverse of exponents. What is 6 squared? 36. But now when you see this symbol, square root, it's like saying, okay, what number to the second power will give you 36? And you work backwards, so that's 6, right? Well, let's cover all of what are called the perfect squares. Square root of 49, 7. Square root of 81. Square root of 25, 5. Square root of 16, 4. Square root of 100. Square root of 100, do you know? Lower. 10. Yeah. 10 times 10 is 100, so square root of 100 is 10. Square root of 121. Good. Square root of 144. 12. Square root of 9. 3. Square root of 64. Square root of 64. What number squared will give you 64? 8. Square root of 4. 2. So that's why we do it. It's okay if you didn't know them all. I just memorize them because I've been doing it for so long, right? Those are what's called the perfect squares. Because you're just taking the integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 squared, 11 squared, 10 squared, and so on. That's about all you need to know off the top of your head. You don't really need to go past 12. You know? This is a cube. So 7 cubed would be 7 times 7 times 7, 343. But now you see this number that's in the root. That means it's a cube root, or the third root. So you can get uber complicated. You could say things like the cube root or third root of 343 is 7. How about another example?
How about if instead of a 3, there's like a 5?
Yes. Let's do, I got to think about it for a second. 32 to the 5th root. It's really bad on the handwriting. So now you have to think. The computer or the homework is always going to give you like an easy number. It's never really going to be a decimal. So you just have to think to yourself, what number to the 5th power would give you 32? Two is the answer, yeah. How'd you figure that out? So you just got to think about it. Try 2 or 3 or something like that. So it's like saying, what number would give you 32? And the answer is 2. So that's a 5th root. One more. How about the 4th root of 81? Actually, 2 more. 3rd root of 27. What number multiplied together 4 times itself will give you 3? How about the third root of 27? Also 3. Right? Because think about it. 3 times 3 is 9, and then times 3 again is 27. Makes sense, hopefully? Okay, we pretty much covered that. I don't think you're going to see the fractional exponent. The same exact thing as a root. This is like writing the square root of 16. This is like writing the third root of 8. It's another one of those things, right? Why does writing a fractional exponent mean the same thing as a root? Who knows? But it's more than one way to write it. Square root of 16 would be 4, and the cube root of 8. Now, like, we're really getting to thinking stuff. Cube root of 8. Two. Yeah. If I have to go back, just let me know. Try to think of an example here. Parentheses always go first. Then exponents. Then multiplication and division. You can kind of do those at the same time. And then addition and subtraction is very last. You will get 2 different answers for these things. Parentheses, quantity, meaning parentheses, 1 plus 3 times 4. Will be what number? 16. Because you got to do 1 plus 3 first. I'm not saying you guys have to do this, but I always kind of write everything out. What number would you get on the right? 13. Because the multiplication comes first. All right. It's a little tough now. Try to throw you some of the harder questions so that when you get to the homeworks, you'll be able to do them, the easier questions. Cube root of 64 plus 3 times 12 over 6 minus 2 times the quantity of 1 plus 3. I'll give you a minute to think about it. What would you like to do first? Do you have any ideas? Okay, so you did 1 plus 3. I'll write every single line out. I'm going around. Next, what would you like to do? All right, yeah. It's a tricky one now, the cube root of 64. Think about it. What number multiplied 3 times will give you 64? Lower. Somebody said it. 4. 4 times 4 times 4 is 64. That means the cube root of this is going to be 4. So we did parentheses, then exponents. All right, good. Next. What would you like to do? Which ones? We want to stay away from the addition because this takes precedence because of the dot.
So we do
3 times 12, what would it be? 36. I'm writing out every step, but you might not have to do that if you kind of think of it and you do 36 divided by 6 in your head, right? But we'll just do it one step at a time. What would you like to do next? Four plus 36 divided by 6 minus 2 times 4. What comes next? You can do the division, or you can do the multiplication. Gotta 36 divided by 6. 6, right. Also let's do 2 at once. Do 2 times 4. 8. Yeah. Very last thing. Go ahead, put them all together. Four plus 6, right? And then subtract 8. 2. It's amazing to me that this whole thing just boils down to 2. You guys probably aren't impressed by that. You're like, I'm like one of those crazy numbers people. Like, yeah, that's wild. 2. Which one do I want to do here? Okay. So if you start to begin to get better at it, like maybe you can kind of think about it and do multiple steps. I'm not saying you have to write out everything at once. For example, this one. 10 minus 3 quantity squared plus 18 divided by 3 squared. I really want to note that the word quantity to you means parentheses. I think that 10 minus 3 is 7 plus 18 divided by, and 3 squared is 9. So I kind of did parentheses and exponents. 7 squared is 49 plus 18 divided by 9. 18 divided by 9 is 2, and I think this whole thing is 51. So you kind of just go through your steps and you get better at it. Ooh. Somebody was asking about this question yesterday, kind of looking ahead, which was good. The length of one day on Saturn is approximately 10 hours, 42 minutes, and 5 seconds. How many seconds is a day on Saturn? Here is our conversion. 1 hour is 60 minutes and 1 minute is 60 seconds. I'm going to have to change 10 hours into seconds. And this is called dimensional analysis. You don't have to know that. But what you do have to know is how to set it up and how to either multiply or divide in order to convert. So 10 hours, I want to change that into seconds. I know that there's 60 minutes in an hour, but the real trick with the fractions here is if I want to cancel out hours, put it on the bottom. And that means minutes go on top. 60 minutes for every 1 hour. And what happens is the hours, you have an hours on top of the fraction and an hours on bottom of the fraction, that cancels. You'll see that more when we get into fractions. But I know I'm doing the right thing because I'm going to be left over with minutes. I'm going to then multiply that again. But I don't want minutes, I want seconds, right? So think about it. Do I want the minutes to go on top or on bottom if I'm going to cancel them? Put it on bottom. Cancel, cancel. And I'm left with 10 times 60 times 60. 36, 30, 1, 2, 3, 36,000? Seconds. Then you have to change minutes. All right, where is minutes going to go now, top or bottom? Yeah, because we want that to cancel again. I know I'm doing the right thing because the minutes will cancel, top and bottom. And now I have to do 42 times 60. No idea what that is.
2,520.
Thank you. 2,520 seconds. Finally, you can put it all together. How many seconds is a day on Saturn? It will be 36,000 plus 2,520 plus 5. Please check me on this. I got 38525. Okay. So 38,525 seconds. Yeah, which number? Which part?
We're at 42 minutes. When it went from 60 seconds to divided by 1 minute was 2,520 seconds.
Yes. How many minutes are in 2 hours? 120. So you did 60 times 2, right? All I'm doing is I'm writing out really formally. If I have 2 hours, I have to decide whether to multiply by 60 or divide by 60. I set up hours on top, hours on bottom. So it's like a fraction. Here's my conversion. 60 minutes for every 1 hour. These will cancel because it's top and bottom, and you multiply across. You do 1 times 1, which is just 1, and then 2 times 60, which is 120 minutes. Right? Say I went backwards, and I say, I have 120 minutes. How many hours is that? 2 hours, because you would divide, right? Well, this just sets it up so you know whether or not to multiply or divide. If I want to cancel out minutes. So now for every 1 hour, there's 60 minutes. Notice that the 60 is on bottom. So I would do 120 divided by 60, which is 2 hours. I mean, I'm explaining it in a crazy complicated way, but it'll help you when you get to like yards, miles, or, cups versus quarts or something like that. But if you can just think of it and say, okay, I got to do 10 hours times 60 minutes times 60 seconds, you can do it like that. Does that help? Okay. Good question. Dimensional analysis. And that's about it. 1.7, 1.8.